All right, let's continue our adventure on polynomials. Today we're going to do some multiplying and some factoring. Another kind of way to look at factoring is like undistributing. Looking for what can I undistribute in a particular expression. So our objectives today is to multiply a monomial by a polynomial and to factor a monomial from a polynomial. So we're going to distribute and we are going to undistribute or factor. You can use the distributive property to multiply a monomial by a polynomial. For example, consider the product 2x times 3x plus 1. So if I've got 3x plus 1 happening here, so I have 3 x's, there's an x, there's an x, there's an x, plus 1, and I am doubling it, kind of, like multiplying it by 2 x's. So I'm taking each one of these x's, here they are, x, 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 and 1, and I'm multiplying it by these 2 x's. So when I distribute that out, an x times an x gets me my x squared. And that can happen here, and that can happen here. But then when I have the 1 times the x, I end up with just x. It happens in my second layer as well. When I have to consider my 2 other x's, and it happens over here. And we call this like an area model, a representation of what's actually happening. We'll look at it numerically either. Also, 1 times x is x squared. So it's distributing this out. If I just want to look at just the straight numbers of it, the algebra piece of it, I'm taking the 2x times the 3x, and I'm taking the 2x times the 1. As we can see here, distributed out, and I get 6x squared plus 2x. And that's what happens in my area model. I have 6 x squareds, and I have these 2 x's. And I'm bringing them together to get my entire area model. What's a simpler form of negative x to the third times this polynomial? Remember, what I'm doing is I am distributing this out to all 3 terms in there. So negative x to the third times 9 times x to the fourth. So I'm going to end up with a negative 9. That I know. And I've got x to the third times x to the fourth. So I'm going to add those together as multiplication and what we've learned about exponents. 4, 5, 6, that's going to be 7. Let's look at my next term here. A negative times a negative will be positive. My coefficient over here is 1, and that's a 2, so that's going to stay at 2. Look at my exponent, so it's an x to the third times x to the third, so I'm going to end up with x to the sixth. Let's distribute this out to the third term. I have a negative times positive, so it will indeed be negative. I have 1 times 7, so it will stay 7. I have x to the third times nothing out here, so it stays x to the third. The one that matches this is D. All right, why don't you try it? I want you to distribute out 5n to this polynomial. Keep an eye on those negatives. Press pause. All right, how'd you do when you distributed that out? Keep an eye on your exponents. All right, let's keep going. Factoring a polynomial reverses the multiplication process. That's why I called factoring like undistributing, and that's what we're going to do right now. We do that by finding the greatest common factor. So we're looking for the greatest common factor of these terms right here. So these 3 terms in this polynomial. So let's look at 5 times x to the third power. The different pieces that make this up is 5 times x times x times x. For my 25, I see 5 times x times x. And for my 45, I see 3 times 3 times 5 times x. So I brought it all the way down to my factors, my prime factorization of these pieces, and I'm looking for what's common. So I'm looking for the greatest common factors, so I want to like all of them. So there is 5 in all of them, so 5 is it, and there's an x here, an x here, an x here, and that is it. This is my greatest common factor of these 3 terms. Why don't you give it a try on this one? Press pause and see what happens. All right, my greatest common factor is 3x. And you'll start be able to do these quicker and sooner without having to write down all these different pieces. You'll start to see them. And this is where actually your multiplication facts really help you out. Once you've found your greatest common factor of a polynomial, you can factor out a polynomial. So you need the greatest common factor to undistribute or factor something. Okay, so let's look at this one. We have a polynomial with these 4 terms. We factor out 4x to the 5th. Those are the different factors of that. 24x to the 3rd. We have the different factors for that. 8 to the x is the different factors for that. So I'm looking what's in all of them. I see 2's and I see x. So my greatest common factor is going to be 4x. So what I can do is I can actually like undistribute. I can pull my 4x out of all of these pieces. And this is how it would happen. So I can see in my first term, 4x to the 5th is made up of 4x times x to the 4th. My second piece is, now remember, I keep looking, I'm trying to pull out that 4x, my greatest common factor, out of all of it. That second piece is 4x times, and here's my negative 6x squared. So 4 times 6 got me my negative 24, and then x times x squared got me to my x to the 3rd. Let's look at my last one. 8x, I'm going to factor out the 4x from that. So I'm going to get my 4 times 2, which gives me my 8, and x times no term gets me my x. And I can simplify that out even more by looking at it as a distributive problem. And I lead off with my 4x times all the different pieces that are left right here. X to the 4th minus x to the 6 times x to the 2nd plus 2. The factored form of the polynomial cleans up like that. So really it is about finding the greatest common factor and then pulling that out from each of the terms. What is it going to take to make that on each term? All right, I want to let you give it a try. So find the greatest common factor of this polynomial, and then I want you to factor it out or undistribute it. Press pause and give it a try. All right, how'd you do on this one? If you notice some interesting things about this, I found my greatest common factor here, and then whatever's going on inside here is actually what's left. Here's another 5x to the 2nd, 5x to the 2nd, and 4, and that's 4. And it's whatever we don't end up using as our factors. Now, if you didn't get a chance to do B, 3B, I would like you to do that. I'm going to clean this up a little bit. So why don't you try B? Maybe you didn't do it because you're not sure what it's asking for. But B is basically saying if you look at this polynomial, write it as a product of a polynomial with positive coefficients and a monomial. So it's basically asking whatever's in, so you've got what's being distributed, but whatever's inside here, will you make this whatever's inside here positive? So I want all of these terms in here to be positive. This out here can be negative, but I want to have all the inside terms positive, and you want to undistribute this or factor it. So you can press pause and give that a try. Okay, for 3b, what I did to find my first term that's being factored out, I looked at each of the different terms and I saw that there's a negative 6 in each piece of this one. So I knew my negative 6. And then I looked at my exponents of x to the 4th and I saw there's x to the 2nd in each one. So then I looked at what was left of each one and what it would take. And by doing this, I ended up with, inside my parentheses, everything's positive. And that's kind of what I'm looking for. I want to make it a positive on the inside. Okay, we're going to do some application here, factoring a polynomial in this helicopter landing pad. We've got some different pieces of this, some different measurements. So we know the area of the square is the side length squared on this one. That's where this is coming from. The area of one is side length squared. So I am going to look at this a little differently. The side length is actually 2x, so I'm going to change that to 2x, and I'm going to square that because my side length is going to be 2x. And I'm going to work that out, and that actually is 4x squared when I distribute that out. My area of my circle on this one is pi r squared. But for, let's see, I'm going to substitute x. I'm going to substitute, what was I saying? I'm going to substitute r for x because my radius is going to be x, so it's pi times x squared. So if I know my square, which is here, my area of my square, so my entire square is 4x squared, and I'm going to subtract my circle, which is pi x squared. That's my area of my shaded region. Yeah, so I can work this out. Let's see if there's anything we can factor out of this. Make this interesting. I can see there's not 4s. I can pull out, looks like I can pull out an x squared that's in both of these. There's my common term. So I have an x squared times 4 minus pi. Looks pretty good. Let's see what else we got. Factor out the greatest common factor. So factor the expression, factor out the greatest common factor. Actually, I did that already. So we're all set. This is one way to do something to apply it in a particular situation, is getting it down to what is my expression once I've factored all the pieces out. I want you to try it on this one. So press pause, see if you can play it out on this guy. And ultimately, when you get your two expressions, we go ahead and factor them out as well. All right, I know it wasn't entirely clear on this one what the area of the shaded region is. I saw it as this area, so I needed to take my square and subtract out the circle to find out that shaded region. I had to take my side times side and put in 6x for that. That's why I got 36x squared. And then from my circle, I used pi r squared, but my radius actually was 3x, so I had to square both the terms. That's something that you got to keep an eye on. You got to square the 3 and the x, so that's why I end up with pi 9x squared. And once I had those, I knew that I needed to subtract those out, but I built my subtraction problem, my polynomial, and then I factored some pieces out. I was able to see, I looked at my 36 and I looked at my 9 and I saw I could pull a 9 out of that. I saw that my x squared and my x squared was in both terms, so I factored that out, and that's how I end up with 9x squared. And when I compared my 9x squared to 36x squared, I knew that 9x squared times 4 would get me 36x squared. And then I looked at my 9x squared and pi 9x squared. I saw the only term that was missing in there was my pi, so I had to include that. All right, make sure you keep practicing this stuff. I'm going to go make friends with a salamander.